In this video, we will discuss derivatives of logarithmic functions. The derivative of the natural logarithm function. The derivative of the natural log of x is 1 over x, where x is not equal to 0. Find the derivative of f of x equals x times the natural log of x. F prime of x is equal to x times the derivative of the natural log of x plus the natural log of x times the derivative of x, which is x times 1 over x plus the natural log of x times 1. So the derivative of x times the natural log of x is equal to 1 plus the natural log of x. Find the derivative of g of x equals the natural log of x divided by x. Using the quotient rule, g prime of x equals x times the derivative of the natural log of x minus the natural log of x times the derivative of x all over x squared, which is equal to x times 1 over x minus the natural log of x times 1 over x squared, which is 1 minus the natural log of x over x squared. As with exponential functions, we expand the number of logarithmic functions we can differentiate by establishing a variation of the chain rule that applies to these functions. If f of x is a differentiable function, then the derivative of the natural log of f of x is f prime of x over f of x, where f of x is greater than 0. Find the derivative of the function f of x equals the natural log of x squared plus 1. Using our variant on the chain rule, f prime of x equals the derivative of x squared plus 1 over x squared plus 1, which is equal to 2x over x squared plus 1. Differentiate the function y equals the natural log of x squared plus 1 times x cubed plus 2 to the 6th power. We will first rewrite the function using the properties of logarithms. Y is equal to the natural log of x squared plus 1 times x cubed plus 2 to the 6th power, which is equal to the natural log of x squared plus 1 plus the natural log of x cubed plus 2 to the 6th power, which is equal to the natural log of x squared plus 1 plus 6 times the natural log of x cubed plus 2. Now it is easier to differentiate the function. Y prime equals the derivative of x squared plus 1 over x squared plus 1 plus 6 times the derivative of x cubed plus 2 over x cubed plus 2, which is equal to 2x over x squared plus 1 times 6 times 3x squared over x cubed plus 2, which is 2x over x squared plus 1 plus 18x squared over x cubed plus 2. Find the derivative of the function g of t equals the natural log of t squared times e to the negative t squared. Again, our first step is to rewrite the function. G of t equals the natural log of t squared times e to the negative t squared is equal to the natural log of t squared plus the natural log of e to the negative t squared, which is equal to 2 times the natural log of t minus t squared. This is pretty simple to differentiate. G prime of t equals 2 over t minus 2t, which is equal to 2 times 1 minus t squared all over t squared. Personally, I prefer g prime of t equals 2 over t minus 2t, but both are correct. The task of finding the derivative of a given function can sometimes be made simpler by first applying the laws of logarithms to simplify the function. This process is called logarithmic differentiation, which not only simplifies the calculation of the derivatives of certain functions, but also enables us to compute the derivatives of functions we couldn't otherwise differentiate using the techniques we've studied so far. To use logarithmic differentiation, we take some function y equals f of x and apply the natural logarithm to both sides, giving us the natural log of y is equal to the natural log of f of x. Then, taking the derivative of both sides of the equation, we get y prime over y equals f prime of x over f of x. Then we multiply both sides of the equation by y to get y prime equals y times f prime of x over f of x. Differentiate y equals x times x plus 1 times x squared plus 1 using logarithmic differentiation. First, we apply the natural logarithm to both sides of the equation and rewrite the right side using properties of logarithms. The natural log of y is equal to the natural log of x plus the natural log of x plus 1 plus the natural log of x squared plus 1. Differentiate both sides, giving us y prime over y equals 1 over x plus 1 over x plus 1 plus 2x over x squared plus 1. And finally, multiply both sides of the equation by y for our solution. Y prime equals y times 1 over x plus 1 over x plus 1 plus 2x over x squared plus 1. But since y is equal to x times x plus 1 times x squared plus 1, that gives us y prime equals x times x plus 1 times x squared plus 1 times 1 over x plus 1 over x plus 1 plus 2 over x squared plus 1. Differentiate y equals x squared times x minus 1 times x squared plus 4 quantity cubed. Apply the logarithm and rewrite the equation. That gives us the natural log of y is equal to 2 times the natural log of x plus the natural log of x minus 1 plus 3 times the natural log of x squared plus 4. Differentiating both sides, we get y prime over y equals 2 over x plus 1 over x minus 1 plus 6x over x squared plus 4. And multiplying both sides by y gives us y prime equals x squared times x minus 1 times x squared plus 4 quantity cubed times 2 over x plus 1 over x minus 1 plus 6x over x squared plus 4.